In this video, we're going to go through two examples for confidence intervals for the difference between means. And so there are 4 steps you always follow when solving for confidence intervals. You need to define all of the information in the problem, and since we're dealing with means, you're either going to be given a population standard deviation or a sample standard deviation. You then need to check the assumptions for the problem, and when you move forward, you're either going to use the formula with Z star or the formula with T star, depending on if you have a population standard deviation or an unknown population standard deviation. And then we interpret our results as we have before. We say there's some % confidence that the parameter of interest is between the lower and upper bound. So let's look at an example. It is of interest to estimate the difference in the mean age of all male students at VCU and the mean age of all female students at VCU. There are 2 populations of interest, all male students at VCU and all female students at VCU, and the parameter of interest is mu1 minus mu2, the difference between the means. For all male students, suppose the standard deviation of the ages is 4.5, and for all female students, suppose the standard deviation of the ages is 3.7. A simple random sample of 31 male students at VCU is selected with a sample mean of 21.3. An independent simple random sample of 35 female students at VCU is selected with a sample mean of 22.8. Estimate the difference in the mean ages of all male and female students with a 95% confidence interval. So if we look in our paragraph, we can first find our sample means for each of our samples. The males have a mean of 21.3 and the females have a mean of 22.8. We are also given population standard deviations for the male and female students of 4.5 and 3.7, and we collected simple random samples of 31 and 35 for our male and female students. Once we have all of this information, we can check our assumptions. We have 2 independent simple random samples, and when we check our central limit theorem, we are not told of any distributions for our populations, and so we can compare 31 and 35 both to 15. Both are greater than 15, so our assumptions are satisfied. Then we can move forward by using our formula for a confidence interval. We can plug in all of our values, and since we have a 95% confidence interval, our Z star is 1.96. When we plug in all of these values, we find a lower bound of negative 3.5 and an upper bound of 0.5. We can interpret these results by stating that we have 95% confidence that the difference in the mean age of all male students and the mean age of all female students is between negative 3.5 and 0.5. Let's look at a similar example where now the distribution of ages of all male students at VCU is heavily skewed. A simple random sample of 50 male students at VCU is selected with a sample mean of 22.3 and a standard deviation of 3.5. An independent simple random sample of 35 female students at VCU is selected with a sample mean of 22.8 and a standard deviation of 5.4. Again, we need to estimate a 95% confidence interval. In this problem, if we first look at our male students, our sample is of size 50, and we have a sample mean of 22.3, and we're given a sample standard deviation of 3.5. And if we look at the female students, our sample is of size 35, and we have a sample mean of 22.8, and we're given a sample standard deviation of 5.4. With this information, we then need to check our assumptions. Again, we have 2 simple random samples that are independent of one another. And when we check our central limit theorem, now we have a distribution of ages of all male students at VCU that is heavily skewed. And so we need to compare N1 to 40. And we're not told of the distribution for the female students, and so we compare N2 to 15. N1 is greater than 40 and N2 is greater than 15, and so both of our assumptions are satisfied. Now when we move forward, since we have sample standard deviations, we need to use the t-distribution, And so when you're solving for the test statistic here, you're going to use the degrees of freedom for the smaller sample size. Here we have 35 female students, which is a smaller sample size, so the degrees of freedom will be 34, and you should know how to solve for your test statistic for this problem. And when we plug in all of our values, you find a lower bound of negative 3.582 and an upper bound of 0.582. And we can interpret these results by stating that we have 95% confidence that the difference in the mean age of all male students and the mean age of all female students is between negative 3.582 and 0.582. In the next two videos, we're going to learn how to use the graphing calculator for these problems. And using the graphing calculator, you will not have to compute a test statistic, so it's usually easier for students.